All right, let's talk about logarithms. First thing, why? And so imagine if we had a problem, 3 raised to the power of x equals 12. To solve for the variable as an exponent, like we have right here, that's where we need logarithms. Now, where do you use logs at? Well, really all over the place. Finances, anytime we have compound interest. The Richter scale uses logarithms. If you get into needing to measure radioactive decay and half-lives, pH in chemistry, decibels when you talk about sound. So we use logarithms all the time, really. So there are two groups of logs. The first group we call common log, which is where we use base 10. Now, most of the time we simply write log of x or log of something, but it's implying base 10. Okay? Now here's what it says. This says base 10 raised to some exponent equals x. In fact, let's do a couple of examples here. Take your calculator out and find the log key and go push log of 100. And of course, it should pop up with a 2. So what this says, and again, what's implied here with all these is that this is base 10, all right? What it says is 10 raised to some exponent equals 100. And your calculator then tells you, oh yeah, this is a 2. So if you push log of 1,000, it's going to give you a 3. And what that means is 10 raised to the power of 3 will give you 1,000. And of course, if you were to push log of 10,000, it's going to give you a 4, which means 10 raised to the 4th equals 10,000. And it also works for small numbers. Here, if you push log of 0.1, you're going to get -1. So that means, and again, these are all, what's implied is base 10 here. So this means 10 raised to the power of -1 is 0.1. If you do log of 0.01, you get -2. Log of 0.001, you get -3. So what that means is 10 raised to the -2 is 0.01. 10 raised to the power of -3 is 0.001. So the log button finds the exponent that goes on a 10 to give you a certain number. Now, base 10 is what we call common log. If we have base E, we call that the natural log. And E is equal to 2.718, and it goes on just kind of like pi would. In fact, if you wanted, you could write this out as log base 2.718 of x. But that's pretty clumsy, and so we just simply go the natural log of x. So now find the natural log key on your calculator. It should be right below the log button. And go ahead and try this. What's the natural log of 27? So hopefully you get 3.2958 and a bunch of other numbers. So what that means is that E raised to the power of 3.2958 is approximately equal to 27. And again, of course, E is, in fact, another way we could write this would be 2.718 raised to the power of 3.2958 is about 27. Let's try one more case here. It's kind of a special one. So down here, what this means is, and again, a natural log implies base E. We're saying E raised to some exponent equals E 7.3. And of course, you can look at that and tell right away, just, oh, 7.3. So the answer here is x is equal to 7.3. All right, moving on. Again, when you push the log button, it tells you the exponent that has to go on a number. Typically, if it's common logs, it's going to be base 10. If it's natural log, it's e. Now, I want to point out there's a couple special cases, and there's a few that don't work. So let's try. Here's one that doesn't work. If I say log base 5 of -3, for example, equals some number, this means, right, 5 raised to the power of x equals -3. And if you think about that for a moment, there is no exponent, a 0, a -2, a +2. There's no exponent you can put on a 5 to make it into a negative number. So this one here is not possible. So this number here must always be positive to work. Okay, let's think another couple special cases here. What if I have log base 5 of 1 equals some number? So what this means is 5 raised to the power of x equals 1. And if you think about that for a moment right away, you'll recognize that the only thing that will work is x has to be equal to 0. Okay, another special case. Log base 5 of 0 equals x. What we're saying is 5 raised to the power of x equals 0. And there's no way we can get that, right? So this is not possible. Now, if we think about the exponent itself, let me write out this one more time. If I have log base 5, and I'm picking base 5 just randomly, it could be any number here, and let me put the variable y equals x. So if I were to, again, this says 5 raised to the power of x is equal to y, correct? Now, if you think about this, if this is a positive number, this becomes big. And if the exponent is negative, the answer is it's going to be something small. Okay? And you could see that when we were working with the common logs just a few moments ago. Positive exponent, we ended up with 10,000, big numbers like that. A negative exponent meant we actually had a decimal number, right? Okay, let's pause here.